Hello everyone, it's me Guilherme, and welcome to the second part of our multiplayer series. Now that our players can create and connect to servers, they need an actual game to play. For this demo, we'll take a look at a 2D shooting deathmatch game. Even though the game is small, with it we'll be able to see how to spawn and respawn players and different approaches to sync data. The first created player either on the server or clients is the player himself. That is because we use the same scene for the player himself and for the other connected players. In other words, the other peers of the network that you're connected to. This happens on the ready function of our game script, which is attached to our game scene. The player scene gets preloaded and instantiated. And then this node's name is set to the network unique ID. In Godot, every node in the game tree needs to have an unique name. As the function name suggests, the peer has an unique ID, and by setting the node's name to it, we don't run into any problems. Another advantage of doing so is in the case we need to access this peer's player scene from a different location. By having the peer ID, we can get its node easily by checking the name. Then the player scene network master is set to ourselves by using the setNetworkMaster function and passing our unique ID to it. The network master of a node is the peer that has authority over it. As soon as we get to the player's code, we'll get to see where this comes into play. Finally, the init function is called on the newly created player, passing three parameters to it. The first one being the player's nickname, the second one is the initial position of the node, and the third one is used to determine if this is either a slave player or a master one. In this case, it's a master, so we pass false to it, meaning it's not a slave. Now I'm going to open the player script. At the beginning, we have two constants that are used to define how fast the player moves and its maximum health. An unknown is used to know in which direction the player should move on each frame. As it is, the player can either not move or move to one of four directions: up, down, left, or to the right. After this, we have two variables that have the slave keyword before them. This means that these variables will have their value set by the master of this scene. In this case, we have a vector2, which is used to sync the master's position with the slave, and also an unknown of type moveDirection, that's used to simulate the movement of the slave based on the master's inputs, also known as the player himself. And then there is the health points variable that holds the player's current HP. This variable is initialized with the same value as the max HP constant. Now inside the ready function, all of what we are doing is calling updateHealthBar to correctly set the player's health bar's value. In physics process, we check for inputs and move the players accordingly. The direction variable is used to know in which direction the player has to move in this given frame. It's initialized with a value of none in case no inputs are given by the player. A check is made to determine if this is the master, and if it is, we're going to check for inputs. Depending on the pressed action, the previously created direction variable receives a value accordingly. After checking for inputs, a network-specific function called rsetUnreliable is called, and it sets the slave position to be equal to the current position of this node. The same is true for rset. The main difference between them is that in the first one, the engine does not guarantee that the information will indeed get to all peers. In fact, it might not even reach any of them. The benefit of using it is performance. It's also important to note that every function that does a remote procedure, for instance RPC, RPC_ID, etc., has an equivalent _unreliable one, as you can see here on the rset and also on the rsetUnreliable. And in this case, there is no problem to use rsetUnreliable to set the slave position, as it's only used to sync the slave's positions to their masters. And this is done on every frame. So if the information is not received, the peer will most likely receive it on the next frame and update itself correctly. In case of this check-in failing, this means that this is not the network master and it is a slave. So all we are going to do is pass slave movement to the move function and set the slave's position to be equal to the master's. And finally, we do a check to see if this is the server. If it is, we save the scene's current position in the case of another peer connecting to the network. This way, the slaves get created at an updated position on the newly connected peer. The move function matches the received direction to determine in which direction it's going to move the player. In the case that the movement goes either to the right or to the left, rifle right and rifle left get called accordingly, making the rifle face the same direction as the player. The update health bar function passes the player's current health points to the health bar value so it can show it on the bar correctly. After that, we have the damage function, which is used by other scripts to damage the player. In this game, it's called by our bullet once it hits the player. It subtracts the current health points of the player by the received value, checks if the player died, and updates the health bar value. In the case that the player died, it does an RPC calling a function called _die. This function has the sync keyword before it. This means that when an RPC is done, this function will also be called on the peer that is doing the RPC. The function then starts a timer, stops the physics process of the player and stops the process of the rifle, hides all of the nodes that are children and can be hidden, and by the end disables the collision of the player so it won't get hit while respawning. When the respawn timer times out, a function called onRespawnTimerTimeout is called by the engine. This function does pretty much the opposite of what die just did. Restarts the physics process and enables collision once again and sets the player's HP to its maximum health. And finally, we have the init function of our player, which is used when the player scene gets instantiated. The first thing it does is setting the label text to be equal to the nickname that it received, sets the global position of this player to be equal to the start position that it received, and then it sets a different texture to the sprite of the player in case that this is a slave. This gives us a nice effect where the player will always see his character with the original blue color and all other players with the color green. And here you can see this effect in action. In this instance of the game, the blue player is called Nathan and the green one is called Guilherme. But in this instance of the game, the blue player is Guilherme and the green one is Nathan. So each player sees their own character with the color blue and all other enemies with the color green. Thank you for watching this video. If you have any questions, please feel free to leave them on the comment section and I'll see you in the next video.